So this is lesson 9.2 translations. We're also going to talk about vectors, which is in 8.7 within this lesson. But a translation is basically where you take all of the points of the figure and you move them the same distance in the same direction. So you're not changing the figure at all. You're preserving its angles and its lengths, and it's staying the same shape. So we're not changing the shape at all. It should still be congruent to its pre-image. We are just moving it, sliding it. Okay, so it's preserving the distances and the angles. What is the difference between a translation and a reflection? So you can kind of think about that after we maybe talk a little more about translation. So for this figure here, are we sliding it? So you could use your patty paper and just see if we could slide that figure onto that other figure. But if you see that we slide it, it would kind of be like this figure if we kind of slid it. Something to that effect. So no, it's not being slid, it is being reflected there. So a no for that one. And then if we take this one and just kind of slid it down, you can see that all of those are just sliding the same direction. So yes, this is a translation. All right, so here are kind of the steps for actually doing a translation. So it helps to draw kind of some parallel lines, or from our vertex point, just straight out the same direction and distance of our vector from each of the vertex points. So I'm going to show you how to do that for this example too, but you don't really need to spend too much time without it being in a coordinate plane, because we're going to pretty much from here on out be using a coordinate plane, but it's fun to practice without. So now let's get into what is a vector. So a translation is a transformation where all those points are moved the same distance and direction. And the method that it is moved by is through the use of a vector. In mathematics, a vector is a way to identify the direction that one point is moved in a coordinate plane. So this fancy V is identified in kind of two ways. We can have kind of these little pointed, not parentheses, but those bracketing symbols there with an A and a B. This A is actually however much we are moving left or right. And then our Y is our second term, our second term is what is added to the Y, and that is moving it up or down. So I like to kind of write that. So this is left / right, and this is up / down. Okay, so A and B are indicated how far the point is moving in the X and Y direction. Okay, so let's go ahead and look at this. We're going to write our vectors here in component form, so kind of our little pointed parentheses. And it looks like we are moving left 5 and up 3. So that is going to be when we go right 5, it's positive 5. And when we go up 3, it's positive 3. So this is again our up and down, and this is our left and right. Man, if I could get it right. And then the second number is our up and down, kind of like an X and a Y. So our X axis and our Y axis is kind of our change there. So the next one is going to be over right 3, so 3 is our first number, and up 5. So 5 is our second number with brackets, with the little pointy, and then our comma between them. Kind of like a point, but we're talking about a vector, a change, so it's not parentheses. What if it doesn't start at the origin? We're still looking kind of at our change here, so we're going to go over 3 and up 1, 2, 3, 4. And then go ahead and try that last one on your own, and let's see how you do. Now this one's just a little bit trickier because we're actually going down 5 and right 5. 1, 2, 3, 4, 5. So this is a positive 5 and this is a negative 5 for your distance horizontally first, and then our distance up and down 5, so negative 5. So let's take a look and see if we are adding something to the first X value there, that is going to move it left or right. Okay, so horizontal, we're adding to our A. If we are moving something vertically up or down, we're adding it to the B. And if we're moving it left and right and up and down, then we're adding something to both, kind of our X and Y coordinate in a sense. So let's take a look here. We have our original, which is D, E, F, and then we have our D prime, E prime, F prime. So what that means is that we have, remember it's our notation for our new image. So this is kind of our pre-image, and then we have our new image. So let's go ahead and we're going to change it -4. So that means we're going to go left, and then a +7, that means we're going to go up. But we're just going to take and subtract 4 from our X and add 7 to our Y. Okay, so that's our equation. So each of these values, we're going to take -3 and we're going to subtract 4, so -7. And then we're going to add 7, so that's going to be a 6. And then here, -4, that's 1. Add 7, that's 4. -4, that's -8, and add 7, that's 3. What you can also do is take from each point and go left 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6, 7, and then you've got your F prime and you can identify it. So you can kind of do it two different ways. Some people like to do it kind of like the mathematical way, and some people like to do it the more visual, physical, counting way. And -8, 3, oh, we already got that one. This one was our E prime, and then we need our D is at, oh, that was our D prime. There we go. And then we need our E. Nope, that was E. Where's D? -7. There we go. -7, 6. So that's our D. This was our E. I was right. Okay, and then we'll connect them. Hopefully you're using a straight edge. I do not have in this application a straight edge, otherwise I would. All right, so real world application here. Mrs. Rushing, I am at 2.7. So I'm going to put an R for rushing. Miss McWhorter is at -1, -5. I'm going to put M for McWhorter. Waldron is at 6.2, W. And Byach is at -7, 2. Okay. So it looks like when Mrs. Rushing throws the frisbee to Mrs. Byach, what vector path does it follow? So Rushing to Byach, here it is. So what vector path? Well, it looks like we went over 1, 2, 3, 4, 5, 6, 7, 8, 9, left 9, so -9. and then we went down 1, 2, 3, 4, 5. So -5. So left is negative and down. I think I counted that right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9 and 5. Negative. So I want you to try this next question. If Mrs. Rushing throws to Mrs. Byach, who throws to Miss Waldron, who throws to Mrs. McWhorter, then what vector would Mrs. McWhorter have to throw to reach Mrs. Rushing? So basically, this is our question here. What's our vector from McWhorter to Rushing? So go ahead and try that, and we'll check when you're ready. All right, so here's from McWhorter to Rushing. So it looks like we are going right 1, 2, 3, and over. And then let's count how much we're going up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you should have 3, 12. Right and up are both positive. And again, this is our right/left, and this is our up/down. All right, so try this this next one on your own, going from this figure over here to the right and down. What would the equation look like? So x plus or minus a number, comma, and y plus or minus a number. How's it moving? And then your vector is this form right there. So try that, pause, and then check when you're ready. We moved right 8 and down 2, so plus 8 for the x, minus 2 for the y, so 8 comma -2 is in your vector. All right, last one, we're going to translate it 3, -2, so that means right 3 and down 2. So I'll give you all of your points over here in case you want to do it, but I'm going to have you either use the points and then add 3 and then subtract 2 from your y, or you can do it in the graph. All right, and double check your number 6. Make sure again that you are using a straight edge. I just don't have one in my program, but lines are straight, so make sure that you are using a ruler, and double check your points and that your figure slid right 3 and down 2.